out there in the world. Yeah. Good. All right, folks. Good morning. Good morning. We are live. So I want to thank everybody for showing up, especially all those who made it out in person and got to enjoy the best cookies in the world that Lucas brought with him from Argentina. So everybody here in person got to have that experience, which is an unexpected bonus. So we all appreciate that. Yeah, I mean, the goal of today is to have a presentation and then also a conversation. And where we're trying to go is to get SCIP into the marketplace so that end users can appreciate its benefits. And a lot of the people that are here already understand the capability, the potential, what you can do with SCIP. And this is an outstanding opportunity to figure out how to do that. And so the idea is that we're basically bringing more engineers and architects on board so that they understand how to work with SCIP in design. So this presentation, we have the pleasure of having Lucas from Casa Forma with us, Lucas Bellani. And he has over 17 years of experience designing SCIP structures and building SCIP structures all over the world. And so we're really grateful that he was able to come out and be present today and share his knowledge with us. We're going to be doing, he'll do a presentation and run us through it with calculations and everything. If you're online, we'd like you to go ahead and just type any questions you have in. We're going to try and reserve questions till the end. If something comes up that we need to address in the moment, we'll do that. And then all the folks here in person, you have notebooks. Go ahead and write your questions down, and we'll try and address it all in an end in a somewhat ordered fashion. And then the folks, we'll try and get all the questions we can that are answered. And so we'll go over the basics today. Lucas is also available for consulting. So if you're looking to do a design project or an engineering project and you would like to have some consulting services done on it, Lucas is a good resource for that. So we'll make sure his contact information gets posted in the chat so that anybody who wants to reach out to him can reach out to him for design consulting services and unique solutions, because it's not always a cookie cutter world out there. I think everyone knows that. So he can help you figure out how to customize your cookie. So without further ado, Lucas Bellani, it's all yours. Thank you.
Well, thanks everyone, especially you, Tom, you, Shelby, and well, everyone that works for this presentation and everyone that is here on following us on the web. As Tom mentioned, there's so much to say about SCIP, but we will focus on the basics, and we hope that later on we can get into more topics that can illustrate you so many ways to use the panel that are not just for what you have in mind, that is just for doing some house or whatever project you have, but there's so much from swimming pools, from tilt up, from precast, and on forms. There's a lot of to chat about, but let's focus on this, and I hope you like it. Well, the first thing that we had to understand is the concept of the way the panel works. Okay, so for the concept of the way the panel works, as it's here on the slides, we can see that basically it's like a concrete structure. The difference is that it's a lightened one. Okay, why? Because the core is out of EPS, so that means that is almost weight nothing, I mean the core, and provides a place to run all the facility that we need, and basically all the insulation, okay? And also, I mean, the way it is combined also improve the acoustic insulation, because it's work with another frequency, okay? Concrete has one frequency and EPS has another, okay? So it match well to get to a very good acoustic insulation. So what we have to understand is that the mesh provides us with all what we need for two things. I mean, the first thing is that the mortar gets thick, okay? So a place where it can be receive the mortar, okay? The other thing is that, so while the mortar will be protecting the mesh as well. Okay. So the other thing is that so the wires will provide us um, with the strength for traction, okay, for pull, okay. So that's what the mesh provides. Then we have these guys here, okay, that runs from one side to the other. We call them connectors, and that's it's what means that the two sides work together. Okay, so if not, I will have just one side and another. So if someone asks you, "Hey, can I have just one side projected and the other no?" No, it can't be done. I mean, you can, but you won't get what you are looking for. Okay, so and then we have so the mortar. The mortar, what is by the strength for compression. Okay, so this is important to have in mind. 'Cause that means that if you have a project that has one floor or another that has 3 or 4 floors, it doesn't change the type of panel. Okay, because that is not implicate that. I mean, because it's up to the capacity of the mortar, mm, and that is out of us for the calculation. Mm. The only thing that is related to that is that, of course, every time that I get more height, it will increase the wind load pressure. Okay, so it might be a possibility that we have to switch panels according to that. Okay? But usually, if there's no implication about the winds, that means that the same panel that you use for one-story home, it will be used for three-story home or four-story home. Okay. Um, and then, so the concept that is mentioned here is that we have like micro columns, which is true. And also we have to keep in mind that usually we use the panel this way, okay? This way it means that we place it vertical, but that doesn't mean that in every time we make it vertical, okay? We can, you know, pull it over and make it, horizontal. And that means that, for instance, if I have a large beam or something, it will be more convenient. So the panel has been tested and used in several countries with several type of panels. I mean, we are here seeing the Chanel panel, but they are another matrix that has been tested and used all over, and with much success. So, well, what we had seen before, it was the most common one. It's just a single panel, okay? So we just have one core of EPS. Can we have two cores like the double panel? Yes, of course. To be honest, it hasn't been used that much, the double core. Usually was brought to, as a product for some regulations in Europe that they need to have a certain thickness of core, okay? So in order to achieve that and not make it that heavy or that weak, whatever, I mean, saying weak is uh, if we can, for instance, this type of panel, we can go up to 11 inches, okay, from one side to the other. Okay, speaking about just mesh to mesh. Okay? So, I mean, if you have that, you will have a lot of insulation, okay, a lot of insulation. You will probably get up to 45 so that would be very good R value. But it would be not that you will lose some stiffness because the relationship between what rigid with the mortar and what is not rigid, which is the core, is a little bit alterated. So, and especially in some places where that's a seismic area can have some issues. Okay? So, so we usually work on what we have here. That is usually panels that go from mesh to mesh. Okay, that would be like we have 4 inches, 5 inches, 6 inches. Okay, that's the most common one. Okay, the double panel, so it has been used usually for when when you want to get over 4 stories, you want to get like 5 or 6. I mean, there will be countries that will allow you to do that with double fund. Okay, invested originally in Antarctica, because there was I mean, a need to get it done quick, okay? So that you pour the concrete, okay, on the center, and then you leave the other, I mean, when the climate allows you, okay, to build it over, okay? So that was back in 88, okay? So then we have the floor roof panels. Floor roof panels, I mean, the single panel can be used also for roofing, okay, or for flooring, but it depends, of course, in calculation and has some limitation. I mean, to do some numbers, you will see that it is okay up to 16, 17 at most, depending on the live loads that you have. Okay? So basically, it's that when you go over that, you have to go, you have to go with this other type of panel that we are seeing here that has some pockets on it. Okay? So why so? I mean, because you have to make it more rigid. Okay, you have to make it more rigid. So that's the reason why we get to have this, and there are panels that have 2 pockets, 3 pockets, 4 pockets, up to 6 pockets. Okay? So, and of course, every time that you have that, two things will happen. One thing, it will get a little bit more heavier because every pocket has to be fulfilled with concrete. And the other thing is that it will be more rigid, more stiffness you will be achieving, and of course, the span will be larger. Okay? What span? Well, you probably get up to 32 feet. Stair panel. Well, stair panel is a very nice panel. Here we have it. To be honest, it's not super used because the way also for manufacturing is not that simple, and it has to be much accurate to the design. In my uh, in my history, I would say that I saw like only 10 panels of that, while I say millions of panels regularly. Okay, because usually what the people does is to place the panel like this, okay, and make the step. Okay, so usually it's more simple than having that. Of course, there's a need, some particular needs when you have usually when you use the panel this way, um, you have to attach it to a wall. Okay, if you don't have a wall and the trail is large, and maybe we have like 14 step or something like that, it comes a time where the stair panel makes sense. Okay, and you do have also a landing panel. Okay, so you have the panel and you can combine it so the staircase can go, and then you can go to each side the second trail or whatever you need. Of course, to attach everything properly, you need meshes. Because the basic is that you have to have continuity on two things. You have to have continuity on the mortar, okay, because it's where the loads came, from top to bottom, and the same for the mesh. Okay, so we have to have continuity on both things. And in order to have that, you have to have angular meshes, okay, which is the angular meshes will they have different lengths according to what you are connecting with. Okay, so if you have, for instance, an interior angle and you are a corner where you have a wall to wall, I mean they will have a length. When you have an exterior and dependent on the thickness of the panel, you probably have one more larger. Okay? Because see, you have to cover the edge that doesn't have anything here. Okay? And you have to ensure that the overlapping is the minimum that is required. So, so, so you use the angular measures for wall to wall, and you use the angular measures for wall to floor, wall to roof. Okay, and then you have the U meshes to take all the edges. Okay, whatever edge you have, yeah, it can be for a window opening, for for a header, it can be for a beam. Okay, So whatever you need, I mean, it has to be. I mean, you can't leave just the foam, okay, without anything else. To be honest, if you project the mortar over the foam, it will stick, but it won't have any structurally, capacity. Okay, so if there's a tiny space that you need to, yeah, to spray the mortar and you don't want to place the mesh, it can be done. I don't suggest that, but it can be done. Flat mesh is it's just I mean, remember that when we do the manufacturing of the panel, at least with the Snell or with Emedu type panels, what you do is to have a block of EPS, and you draw it and separate in pieces according to the design that you look. In this case, with these waves that we have, and then we create a mesh, okay, that we bend it or not like that, and we attach it, out of this connectors, okay, that are properly well. Okay, why I'm saying this is because the flat mesh, it's, you made it out. All the meshes are made it out of the same mesh that is of the panel. Okay, so saying so, that means that the distance between each wire, it is not always the same. Okay, so you can have different length in between one. The only thing that is for sure is that you will have 19 wires on each, okay, vertical wire. And so the flat mesh, the idea is when you have to take out the mesh for whatever reason, basically when you have to put some pipes, some water pipes or whatever, I mean, you have to take it away, you have to cut it and take it away, then you replace that with a flat mesh and you overlap it properly. Well, now we will see a lot of styles of houses that can be done. Well, one story houses here that have been done, lately. See, the aesthetic varies a lot, and we can do this type of multi-level condos or whatever. And you can also combine this with other systems if that, helps you out on, making improves on the timing. Okay, for enclosuring.
Yeah, so I was just going to mention in there, this is, I'm sorry to,
No, no,
just
sorry.
interject for a second. So I should have mentioned this at the beginning, but this is kind of the first presentation of the North American.
Go up to 2 hours usually. To be honest, that depends also on the thickness of the mortar that you place. Okay, if you want to get over, you can. What you have is to place more mortar. Okay, that implicates that one of the great benefits here in America to use the panels is that you probably drop the insurance cost a lot. Okay, because you save. you have a house or whatever construction you have that is fireproof, that is a hurricane resistant, and works well with earthquake. Okay, and of course there's no any other things associated like for the good construction like termites or things. Okay, and of course the maintenance is lower and it complies the code. Okay, so and thermically speaking is even better also usually because the R value are not usually for monolithic. Okay, and this is a monolithic. It's a mass construction, so that means that it works better than the other cases than in framing. So of course, we work here with the different product has their uh, ICC, ESR reports or TER, wherever they have every product, and they have the specs for them and the different approval for every state. So, well, here what we see is some idea of the strength. Usually, I mean, the first thing that we have to focus is in the compression strength. Why? Because then everything are related to that. Okay, and so to get more compression strength, what you need is a better motor. Okay, that's I mean, and when you are working with floor, that's not only applicable for mortar but basically for the pouring concrete. Okay, and so usually for the pouring concrete we will use 3,500 KSI, and this one and for the mortar 4,000 PSI. So that's no KSI, PSI. So that's so basically on bags and that goes for 4,000. Yeah, I mean even for 6,000. No, and so if you wanna every time that you go for that to give you an idea, for only 1 foot, okay, you get around 50 tons, okay, of strength, okay, 50 tons per each foot, okay. So that gives you an idea of the capacity that you have, okay. So meaning that you won't need all that much. But that applies then for every other single thing that you will see on flexural, because everything is related to that. Well, here we are showing the fire resistant tests. I mean, I have to say that another time that this is about the thickness of the mortar that you apply. Okay, and usually the test has been run with loads. Okay, so we ensure that 2 hours are with loads on it. Okay. Well, this is basically why we call the panel, capable for wind and for places for hurricane. Not only because it won't, get turned down by any wind or or being flown apart, but because it can resist the wind impact of anything that is on the way. Of course, you had to contemplate the openings, okay? But that's how the tests are. Well, the seismic performance, what is important to know is that this has the benefits of the strength that has the concrete, but we have another additional benefit, which is that is lighting. So every time that you calculate every seismic calculation, I mean, it's increased when you have more load. Okay, so since this is about half of the weight, I mean, depending on the type of panel that you use, as thicker it is, it is more lightened. So that means that you will reach, a better condition with less cost. Well, ballistic test has been done with, there are some ballistic there at the website that they were made in the 80s. And yeah, that complete not only Magnum machine guns, and then there has been also some tested run by the Pentagon regarding bombs. In that case, they were using double mesh. Double mesh. Or the acoustic performance. Well, the acoustic performance here, we see another time, the decibels that can take, I mean, did say 7.5 panel, okay? But of course, another time that implicates the thickness of the mortar, okay? As much mortar I place, the better performance it is. If we increase a little bit the panel, we will get a little bit more. But about the sound insulation, that is a little bit tricky because sounds are not equal. Okay, it depends on the frequency. Okay, so usually the high frequency are related with can be taken better with the foam. Okay, so if you are in a place where there's maybe in the exterior, the high frequency works well. If you are speaking about a hotel and you are concerned that from one room to the other the people doesn't get the knock or something, that's the low frequency. So low frequency requires more mortar. Okay, so and then there are some places that you can create some choice and something to improve that situation, manually speaking. Well, the performance, as I mentioned, is usually the lowest value that we have is around, 13 R value, and we can go up to 40, something about that, depending on the manufacturer. Okay, that depends not only, on the thickness of the panel, okay, but on the density also of the foam that you're using. Okay. We are using around a pound per square feet here, and it's around 16 kilos per square meter, and per cubic meter, and but you can get over that. If it's needed, usually you don't need that much, and it's super efficiency in comparison with other insulation systems. Well, of course, everything. Well, here is the data regarding the density of the EPS that I told. Well, the steel really here is much better than here that it says 60 KSI. It's about 115 KSI. Mainly. Okay, that was left from another thing. The spray mortar, as we mentioned before, is 4,000 KSI. Okay, and the poor concrete is like it says. But another time, if you can order something better, you can order something better. Something if you order something better, you get to have probably a larger, more capacity, and that allows you to have a larger span. But also, maybe it's for taking out the shoring in less time. Okay, so that's basically how it works. The people that works on precast, they used to have, instead of 3.5 psi, they have 8,000 usually. So, well, that's also, this is, everything is not manually, it has been monitorized, and so of course all the welded and everything has been tested. Okay. Well, what it's about foundation, what is important for you to know at this point is that there are no concentration places. Okay, usually, of course, if you have a very large opening, on the edge of those openings there will be a concentration, okay, of loads. But usually, what it is, you distribute very efficiently the loads. Why? Because everything is bearing. So unless you don't want it, okay? So everything bearing. So that means that, I mean, the way to distribute the loads is linear. Okay. So wherever you mention, you have a footing, you can have a foundation slab, you can have beam foundation, and with piles below. I mean, there are a number of possibility according to your project and according to your soil. Okay. So, I mean, we are right now, for instance, having some cases where we are using fiberglass. There are piles of fiberglass also. There are, a number of possibility that can be done. Okay. The only thing that you have to know is that you always have to have a river, okay, that connects the foundation with the panel. Okay. That river usually is a number 3. Okay. And you will place it every 1.5 feet usually, and it will have like a length about of 16 inches. Okay. And usually you place a mechanical connection product, epoxy, for that. Of course, that it's about also the seismic area and that. So that's about calculation, and you don't have to take it just 100% sure what I'm saying. It depends on every project. So, I mean, with all the family of meshes that we have seen, we have everything covered. Okay, so we have the every edge, to be taken by the U mesh. You have the flat mesh. Usually, the flat mesh that we are using, like here, like on 45 angle, we place it on every vertex that you have, and you place it like half. Okay, it's not needable for you to have that. And one important thing that people may ask sometimes is how I connect panel to panel. Well, they have their overlapping. Okay, one side to the other. I don't have here because this is a cut, okay? But I mean, if it will be an entire panel, you will have the overlapping here, and here we have it on the other way, okay? So usually speaking, you don't have to have any additional mesh to connect panel to panel, okay? You're already covered on that. So here we are seeing another time what we have explained before. So here we see the connections. In this case, it's the cases where we had to take a better look and see if the thickness that we have of the panel, I mean, can be fully covered with the angular mesh, okay? Or we have maybe to combine even an angular mesh with a flat mesh if it's required, okay? It's what we have to see, and that's about, regulation. We had to do, usually it's about a 20% of the thickness of the wire. Okay, so we have to overlap that. So we have to go over that and see if we are okay with it. In this case, well, you will see that then we place a column. To be honest, it's very uncommon that we require to have a column there. I mean, it's okay, it can be done, but usually it's not needable. Right? Same as there. Here, yes, usually it's the way it is. I mean, we have that. I mean, you can even have uh, the panel go up to here, okay, to align with the exterior face of the wall. It can be done. That implicates the type of panel that you are using here. Okay, so as longer the span is, the more the stiffness I require here, okay, on the connection. So this is this is probably a good connection for the panels that has joist on it, okay, and that probably implicates that are very large ones, okay, and therefore they are receiving a lot of load, okay, and the same comes for this, okay. And the way, so the only thing that is important to see here is that, see, the loads here come, basically, okay, the live and the dead loads come here, from the mortar, okay? So if I here have just foam, what it happens is that the foam will have to be distributed with the layer that I have from the compression layer that we have there. Okay. So in order to avoid that, usually this area is out of concrete. Okay. Well, the same applies here. Mm. There's also then a lot of details to show you how to lock in, when you have panels that are not from the length that, I mean, you order a panel that is maybe 19 feet and you have to go over and you have to get up to 30 feet. I mean, there's a way, I mean, you usually lock it like bricks, okay? And the thing when you have this type of panels that have choice on it, is that allows you to have a choice that is totally continuous, okay? So that's prevent you to other issues. I mean, to have a share a place that you can have an issue with that. If you have just the regular panel, the single panel, I mean, it's a little bit more tricky to get connected if you have two panels. Okay. Well, here we see it on a pitched roof. mm. The only thing about the pitched roof is that, of course, we have to see the slump that we are working with. I mean, on the concrete, dependent on the pitch that we have. Okay. And so there might be times that to achieve that, we have to make it on different strips. Okay. Um, and we place ribbons in the middle. So we put something, then we put another and another, depending on the slope that we have. Okay. Well, structural behavior. Well, generally speaking, I think I explain a little bit. Well, remember one other thing is that the mortar that we are speaking about, it's about usually 1.5 inches. Okay, but that 1.5 inches is usually 1 inch over the mesh. Okay, it's 1 inch over the mesh, and the other half inch is considered below the mesh. Okay, and when I'm saying over the mesh, I'm speaking about the guys that are more exterior. So I'm speaking about the vertical. Okay? So from here, depending on the regulations, you can go from 3/4 to an inch. And of course, yeah, if you are underground, the regulation might ask you to two. Okay, so there are things that I- I'm the one that I have to pay attention on. Okay, but regularly speaking, is that so? So you place it on two layers. Okay, in two layers. The first layer is a scratch. What you have, sure that you have, I imagine mainly they have seen some videos about that. You have a scratch. Okay? So the first scratch, what you have is not to see the mesh. Okay? And then the second one, okay, you have the brown coat. Okay, so you leave it like what we say we have the shell. Okay, so everything is already done. I mean, can you make more than that? Yes, you can. I mean, the problem is that, of course, um, the mortar maybe it's not the thing that is more cheap. One of the thing, the other thing is that you are adding more loads. And you have to understand that you can at once just 1.5 inches at once. Okay, so and there's a limit, and the first layer will get attached better than the second. Why? Because the first layer is one that deals with the waves that they have the panel. Okay, and see the density of the panel is if you make it too much. Okay, if you go it over the square feet, you probably get an EPS form which doesn't have like yeah, a point for bounding. Okay, so, so it's super smooth and there's nothing to get with. Okay, so you can get. I mean, it's not convenient for you to that. Why I told you that it is possible more to get fixed to the ear even without the mesh. Okay, so you have that, you have the shape, and you have the mesh. Well, the other is just 7 to 7. Okay? So, so the idea is not to go. I mean, I have seen mortars of 4 inches. I mean, but I wouldn't recommend you that. Okay? I mean, I mean, you have to take cautious on many things, and you will be spending a lot of money. So here, I mean, what you can see is, I mean, the capacity we are speaking right now here. I say that generally speaking, we are mm, mm, probably over the 100 KSI, of capacity of the steel. Usually, we use three, and layer is it's a little bit more. It's 1 inch over the face. Okay, it's over the face, and then what you see here is that each panel, depending on the size of the panel, will go already, with much capacity for flexion, okay, for moment, okay. So that implicates for floors, that implicates for beams, that implicates everything that is horizontal, and also when you have flexocompression. So when you have a load that is coming, from the side, maybe of the wall, we will see that. So every time that you have that, I mean, you ended up having more, okay, more moment. And the other thing that it changed the equation is also this guy and the mortar itself. Okay, so if you go, I mean, here what you get. I mean, remember that I told you that you can probably get up to 50 50 tons per foot. Okay, so that is about that. So, and the way, I mean, if people say, hey, that really, Lucas, how it does work, I mean, and the people usually, I mean, at first, that's I remember the first time I had seen the system, and, and everyone was cautious on, walking over walking over the floor, okay? Because they say, well, this is, EPS. And it, well, everyone, was a little bit. So let's dig into that. So the thing is that you have you have something on the top, which is the compression. Okay, so that is what where we pour the concrete. Okay? So imagine that this is the floor panel. Actually, it can be also in or whatever, but we are speaking about floor panel. So what we have there is what you see on blue are the meshes, okay? The meshes, on top, bottom, and then you have the resultant, okay? So the D will be the compression resultant, okay? And the C will be the tension result, okay? And in between, okay, we have the lever arm, okay? So what it means that it means that every time every time that I have a secret panel, I improve the moment capacity. Okay, so why? It's easy because it's that length. You multiply that. Okay, the value that you have, you multiply several times according to that distance. Okay, to be honest, what you do is divide the quantity of steel that you require is divided by that number. Okay, so what you have is, of course, if you make, for instance, the compression layer higher, what it will happen? Well, first thing, it would get a little bit more large the lever arm, but a little bit. You see where really is the compression is here, is where the D it is. Okay, it's not even centered. Okay, so maybe you get 1 inch over of the compression layer, and you get like the lever arm, you just a quarter of inch you extend. So it's not that you gain that much. Uh, what you other the thing that you gain a little bit is that you get a little bit more of rigidity, more stiffness. That's true, but not, so much capacity for the moment. Because another thing is that when you place more there, you got more load. So So the moment goes, against you in that case. Um, but what you have there below, I mean, the difference between the top and the bottom is that the resultant of the tension is always in the same place. Where? On the wire. I mean, there's no other way that that guy can move. So even if I make a cigarette, I mean, the resultant will be the same. So the lever arm will be in the same place. So it doesn't help me out that much. Okay. So what it implicates that, of course, is another time that you make a little bit more rigidity on that. But let me say that the one of the principles of of the way the skip works is having the attachment, not super rigidity. Okay, so if you want more rigidity, also it can be achieved by making more rigid the attachment. Okay, so I don't know if that's the clever way to make it. Okay? So I I hope everyone understand a little bit the concept. So and to end it up this, I mean you can even put the shoring on bottom, pour the concrete, okay, and take it away the shoring. Let's say 10 days after, or depending on the capacity of the mortar that you the concrete that you place over, and you will come below and take a look, and there's everything white. It's just the EPS, okay, and there's no problem, even because you don't have live loads. Okay? So what I'm saying is that it's not super important, the covering. Structurally speaking, there are another reasons. To prevent everything, corrosion or whatever. There's a number of issues, but structurally speaking, the ceiling is not that important. The more well, so here, in a simple calculation, what we will do is to take, the numbers that comes out on the moments that we have on X and Y, okay, and we will see how they match the quantity of of well the quantity of steel that I have, okay, and have it in mind the labor arm, okay, because that the labor arm is what it will drop the quantity of mesh that I require. Okay, so that's basically, what we have. Then that's the first thing. Then you have to go and see if it matches with the deflection, and that's where we come. I mean, if you don't place the mortar, for instance, on the ceiling, you will have a problem with that. Okay, and that's another time what it happens if you don't use in some occasions, uh, this panel that has choice on it, okay? Because probably the deflection will be higher, okay? And it won't verify that. And usually, what we do, now I'm speaking about Plataforma itself, I mean, as a consultant, um, the first thing is that we have to modulate. Okay, this is not about having columns and beams. Okay, this is just about everything is working together. Okay, so every load is being distributed, to every place. So the way to make that for real and see how it works is to place it over to create a material on the software as a finite element, and that can give us a reference as how is it work. Okay, so of course what you see here are the graphic, okay, the heat graphic they are called, where we see the areas where you see the red areas, to pump you up the places where there's more loads, there, okay, and see if so you have to pay attention there and see if it's capable what you have. And for capable, we will see, okay, if we have enough content, if we have enough steel. Okay? And the idea, one thing that I want to make a point is that you have to understand that this works as a whole. Okay, so I mean it is integrated everything. So that's why you can reach very high cantilevers. I mean, we have done cantilevers that have about 15 or let's say 12 for sure feet, okay, of cantilevers. And that's why, because maybe the lateral walls, are working also as inverted beams, okay? So, or as brackets, okay? Um, so the thing is that you have to understand that that they work as a whole, and therefore you will save a lot of reinforcing, mm, a lot of reinforcing, and that's the goal that we have in mind. And so what you see here is, for instance, how it is performed for the wind, but you do this, for the wind, the live load, the dead load, everything, has its graphics, and you have to go over the calculation, okay? But you don't have to make, what I have here, um, a floor, and there I have a beam, and there, it's not the way it works. And so, of course, we had to take all the codes. We have to see the wind loads, how they are, the risk category. And for instance, here, unfortunately for us, in the southern of Florida, you have to check it out. So you have to check it out every single opening. I mean, for the Miami-Dade County, you have to go over that, and that's a little pain in the ass, but you have to go through that. Uh, yeah, and also to the manufacturer, saying, meaning that he has the correct anchor for that. Okay? So, well, basically, here is what we were saying about that a single panel go mainly up to 16 feet. That's another thing. I mean, depending on the way it is attached. Okay. I mean, it's not the same if you have something that is attached on the four, on the four walls that you have. Also, it's not the same if the proportion of what it calls LX and LY is, if it's LY is twice LX, I mean, that change. Okay? So meaning that if you have here something that is 14 to 30, I mean, it is double the LY. Okay, so that means that you assume that the structure shaft works on the X, on the X. So that's limited the capacity and make that deflection is higher. Okay, and then when you have when we have these guys, I mean, the other thing, of course, is that you mainly assume that it works mainly just on one direction because you have the choice. Okay. Speaking about the double panels, I think I spoke a little bit about. I mean, double panels basically, I mean, they were conceived for getting, very high. I mean, there were cases in Spain that they reached with that. I think they were like 8 floors. Okay. So, and they were up to having, looking forward to have certification for going up 10 floors. Uh, the thing is that, I mean, in comparison with other systems, maybe you get to have something very, I mean, the total, okay, and there's a lot of cement involved. So I mean, I will use it in places, for instance, in cold weather. It's a very good way because I mean, you ensure that the two faces of the core, help you out on the cement dry properly. Okay, so and that so once the concrete is dry already, you have some strength. So you reduce the shoring, okay, and you leave the strain of the mortar from the laterals when the climate allows you. So usually speaking, it's not much use. Um, Here, what we can see, I mean, when someone came over and say, "Hey, Lucas, I want to make this project." Well, I mean, you can either make it the whole as a monolithic, okay, structure, or you can combine it. My advice would be, I mean, if we make combinations, don't lose the essence. What is the essence? We have to have fireproof. I mean, so don't mix it up with wood, strass, or something. I mean, at least 4 floors. Um, Keep the strength for wind. Okay, so all the exterior has to be is mandatory to be on. And then, I mean, remember that as I mentioned, this works on shape. So when you can tell while you are erecting, what it's not working. That one will not. Okay, okay. You are the one that says how it's working on. Let me place it there. It's not that easy in this one. There. Oh no, I was placing the other way around. Now it is. So the what I was saying is that you can tell why you are erecting. You never place a panel alone. Okay, you always begin by a corner. Okay, because that is how it works. It works by shape. Because that provides you inertia. Okay, so you have to work with shapes. You have to create these. You have to create U's. You have to create L's. Okay, so those so what you have to have is that I think there we were. So going back to here, I mean, maybe we can assume that some walls are not necessary. Maybe we say, well, this one, I don't know if it's necessary. Okay, this this one, I don't know if it's necessary. So we have to figure out if everyone is necessary to achieve. I mean, you can go up to the minimum. The minimum will be like, let's say, okay, this wall, I just make it this. Okay, so that will take the window. Okay, so I don't do the whole wall. I just do a part. For instance, if I want to save, everything. Okay, so, and the other thing, when you have the the floor provides you also that. I mean, it's not the same that if you have, for instance, the floor out of tip, or if you have the floor out of frame. Not at all. I mean, it works differently. So, but then if you are clever enough and you can mix it up properly, you can reduce if you want the bearing walls in the interior. I mean, up to minimum. Okay, and create beams or whatever, okay, and go back. And the same for the panels. I mean, you can lay it out like it's here, or we can flip it and place it horizontal. I mean, because that maybe it prevents you to make cuts. Okay, so we say, okay, well, this is 4 feet. Okay, so it's the width of a panel. Okay, so then we make it happen. And for instance, that apply, for instance, for the beams. I mean, can you do a beam places like this? Yeah, you can. The problem is that if the beam is very large, there are two issues. The first thing is that you have to ensure, the connection, and this connection, this overlapping, it's okay if it goes up to the floor, but it's not okay for something that is working as a beam. Okay, so instead of that, if I place it horizontal, I mean, I don't have any joint. Maybe I can go to a beam that has 15 feet and I don't have any joint at all. And the other thing is that, see, the wire that works more is the vertical because it's the one that is more covered. Okay, so that provides you more strength. Okay, so you have to assume what is more convenient for all that matters. So basically, well, this case the same. I mean, probably everything that is here is in blue. I mean, maybe if you don't wanted to make it on panels, and it's okay. I mean the panels. I mean, on our office, the panels are not there. I mean, because it's supposed to be on office, and then it's supposed to change with time. Okay, so if I wanna leave some place, open to a future remodelation, I won't use SCIP for interior. Okay, And another time that is important in these days is to see if you want to make a correction for the present codes, or you want to get, you know, ahead of that. Okay, and meaning that is that I wanted to ensure that my design is good enough for that, you know, future code compliancy, and that so that therefore I can make the insurance, you know, still, you know, being reduced for several years, and make my home, you know, an easy reselling item, and you know, so that's basically, I mean, people maybe come over and say, no, Lucas, I don't want to have the I mean, no, but the code here says it's 130 miles per hour. No, I have, you know, like 2 years ago, there was a security here that it was uh, 30 miles away, and it was 180. I want to go up there. So it usually doesn't take much. Okay, I mean, maybe the only limitation is that on one hand you can make it a combination with another floor system, or with another um, you know, roof system, and the other no. Okay, meaning like, for instance, like for roofing, or other. Okay, so you, I mean, that's the only issue, and so it's important if someone want to contact us, and that, to have that in mind. Well, that is all about. I hope it has been interesting enough, and that the people are still there. And if there are some questions, well, I will gladly respond.
Yeah, we can open it up to questions. Does anybody have any questions on the presentation, or any areas you want to delve a little bit deeper into?
Is the presentation available to us?
Yeah. Yeah, we'll be able to send you a link to it so you can watch the whole thing from the beginning. But really, I mean, we do have some time set aside here for questions. So if you have any design conundrums, thoughts, questions, just things that are sticking out, potential applications, we'd be happy to, or I'd be happy to have Lucas answer them for you. Should be great. Yeah, Joshua.
Yeah, yeah. Let me uh, let me go to that. I think. Yeah, 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 yeah. Let me. This one, where it was. This one. Yeah, yeah, yeah. Yes. Yeah. Yeah, I mean, the rivers. I mean, you can connect on one side only, or two sides. Usually, people try to place it on both sides because it looks a little bit more wise. I mean, it helps out a little bit more for the panel. Okay, provides you a little bit more strength at that moment. And to be honest, I mean, imagine that, except on places where there's a risk, seismic risk, real seismic risk. That's, I mean, usually the weight itself of the structure doesn't allow that to move so much. Okay, so the idea of those anchors is really to prevent that from moving almost in any case from the wind. Okay, that also means that if we have a place where the wind can be heavy, and especially if you have several, I mean, the height of the construction is where you probably get to have more of those. Okay.
So think about the water penetration underneath, and
Yeah.
also if you're doing exterior finished material,
Yeah.
can go down past that. Yeah, that's why I was asking.
No, I mean, usually what you don't have to do is to place this at the same level. Okay, so my detail would be that here we have a recess. Okay, so that's, I mean, basic. That's basic. I mean, but it's not really up to the panelists. I mean, I didn't want to get into that issue because the important here is that it's a linear distribution of the loads.
We have
I
a,
think
yeah.
question is, on a monolithic slab,
Yeah,
the rebar in the footing has to have a 3-inch clearance of concrete,
yeah.
which means the rebar is 3 inches from the edge, and the panel thickness is X plus 1 inch of.
No, but you melt this area, okay? So you melt a little bit to ensure that the covering of that is the appropriate covering.
But again, the point is the edge of the tool is
Yeah,
not flush with the edge of the stem or the base, so it has to be footing. Mm,
I am sorry, I
I'm
don't
not,
fully
I don't like
understand
that.
Are you saying for the slab doesn't come out far enough and you're putting the rebar in and it's about an inch away from the edge of the slab going down?
We just have
Yeah.
to maintain the clearance of the rebar in the concrete,
Right.
3 inches against it. So that's beat it up.
Right. Yeah, or you extend the slab a little bit out and put a small
Yeah,
slope on
if
it.
we extend the step, it's different story. You won't have, and then if you have the finishes, but stuck over other material will be flush with the edge of slab. That's
Well, there are other people that also, I mean, use the edge of the slab will come here, okay, and then the panel is melted and have only this side, and they make it all together. That's another possibility.
Okay, we had a couple questions online. I'll just drop in. We had a question regarding the resistance to hurricanes or strong winds when the panels are just stood up and tied together
Oh,
while it's being built, the process of being
yeah.
built. Do you have any experience to share with that?
Well, the thing is that, yeah, we have a lot of experience about that because, southern Argentina and the East Coast is wild, the wind. I mean, during the process, we don't have hurricanes, but we have that. And of course, it's the shoring. I mean, you have to add more shoring, bracing, and that's all. And and of course, one thing that I always suggest is not to use. For instance, if you have this is has to be clear. If you have a project of 2 story, you never ever place the second story if you haven't sprayed the mortar on the first one. And usually, when you try, I mean, the better is that you have to spray the motor all the outside firstly, okay? And you try to have some interiors, okay? That is the first thing. I mean, it has to be properly attached. Walls that are inside that are perpendicular to those and the floors, okay? Because that helps you out a lot to keep all the panels together. Okay, so having that well done, I mean, you won't have any trouble at all.
Yeah.
Uh, we built a home in Sarasota and it went through 2 hurricanes during.
Oh wow.
And so at one point we had 3/4 of the house shot. The other, and it was all 1 story. The other section of the house was not shot at all, and we had no damage. No panels were pulled off, punctured, or torn. I was really impressed with how everything held together.
Outstanding. Are they able to hear Shelby? Yeah, yeah, we got. I saw a light somewhere. Is it live? Yeah. Okay, great. Okay. Yeah, no, that's great. There's a lot of experience out there, and people sharing that experience gives people faith. Yeah, because if you have a bunch of loose panels, it might secure them down.
Surely.
But once they're tied, yeah, once they're tied together, you're in shape.
And of course, whenever you use seeker panel, it's easier. I mean, no one of them will flew, okay? But the deformation that you can have either for very strong winds while you are spraying the mortar, or for the pressure of the mortar alone, okay? Every time that instead of using a for each panel you probably get better on that situation.
Okay, we have another question online that was, and we kind of touched on it right now, but the question was based on how are we doing the floors, like the inner story floors?
Yeah.
Are we, doing precast and setting them in place, or are we tying them in place and then doing the concrete projection at that point? I think you touched on that a little bit.
What we have seen today is everything about the basic, and the basic is spray mortar. Okay,
Right.
but as I mentioned earlier, there's another techniques. You can use the panels in type forms. Okay, I don't want to dig so much in this because maybe the people get confused, and I hope later on I will do it. And what is about precast? The same. Precast has different as forms. It's you can use with concrete that are of higher strength mortar. What I told, and also you can make the covering much thinner usually than pouring from because the thing is that how much fluid is your concrete, okay, the slump that you have, okay.
Right.
So when you have to drop it and pour it on top, and depending on the type of foam that you use. It's not the same if you use a good foam that you use PVC foam, for instance, okay, or in the middle you have aluminum. So and the thickness that you have, okay. So that, but in the basic is that having just 1 inch over, it's almost impossible. Okay, it depends also on the height. If you are using panels that have 8 feet high, or you are using, I think they are up to 10 feet high. Okay, so depending on that, the thickness that you will have to use.
Okay. But generally, for like the inner story floors,
No,
it's basically what you said. You spray the outside
yes,
first, you spray the inside,
yeah.
ceiling, shore everything, or everything shored, and then you're
Yeah,
pouring
but
on
the thing is that you already placed the floor panel. You already connect them.
everything tied
Okay,
together.
so everything has to be tied together. As you have here on your model outside.
Mhm.
And that keeps that strength. If the model that you have right now outside,
Mhm.
you take it out the roof, you will see how it moves. That's
Right.
clear enough.
Yeah. Everything's tied together first.
Yeah.
Outside, inside ceiling, and then
Yeah,
pour on top.
that's an issue. For instance, when you're thinking about some modular homes that has been done with that, and sometimes you don't have the roof for various reasons. Maybe you can go to a bridge or whatever, for the clearance it has, and so that implicates that maybe you have to go with some brace, you know, uh, to keep that tight, while you are moving, for
Mhm.
instance. Okay, so that means that the roof are very important to keep everything together.
Burning questions? Mhm.
Thank you. You mentioned that you can use the whole panel as a header or a beam spanning so many
Yeah.
feet if you turn it 90 degrees.
Yes.
Do you have those values tabulated, or you have like a design tools online that the designers can use?
Well, basically the pre-design of that, the pre-calculation of that is about 10% of span, okay, just for the height, okay, and then you calculate the rebars that you will need. In the meantime, there's another thing to contemplate whether you integrate it fully. When I'm speaking about the 10%, it depends of here. My arm is the floor panel. Okay, so if you fill this area that connects one to the other with concrete, that will be one thing. Okay, so I can on that 10% contemplate the thickness of the floor panel, or if not, if I don't, if I don't have concrete there, the 10% goes from bottom, okay, of the floor. Okay, that's the idea. Then you have to do the math. That's for pre-designing. Okay? And what it's about the pre-designing overall, I'm speaking about basically the walls and the floors itself. Well, there are some tables, okay, that tells you, for the backing risk that you have, for instance, in the case of walls, okay, the shear capacity, okay, and everything about that. So you can say, which is the maximum height that you can reach, for instance, on walls. And the same applies for floors, where also you keep out the buckling and you incorporate the deflection. Okay, so there are tables that shows you an idea of which panels will fit your requirements. Okay, taking notice of the live loads that you have.
So just to, uh, now so we have an 8 10 foot slide.
Yeah.
We have about 2 feet of header height for the wall. Do you recommend just designing a cast in place beam with rebar by designer, or you have some tools available online?
No, I don't have. Yeah, we have to define that. Yeah,
Okay, so you can't really use that wall panel as a
yeah. Like a header. Yeah, yeah. If even if you, the floor panel, for instance, if you don't want it to have a header, okay, and you have if I'm understanding well, you have a sliding door, you say,
Mhm.
okay, but the sliding door, the place where the slide gets inside the wall can be a wall out of skip, okay. That is not possible, okay. It won't work. Because we have the connectors in the middle.
I'm just talking about the header itself.
Okay, the header, yeah, we use the header panels as a header, yeah,
So you
usually.
have those tools available for tables.
Well,
Let's say for a 10 foot span over the slider. Is it
okay,
something I can
the
use?
10 foot, as I mentioned, probably requires like 3 foot, okay, of header,
So you
usually.
have that.
Yeah,
You
it's
have it
like
available.
about that 10%. Then you have to dig a little bit more. I don't know like those that you have and other combination. Just to have something in mind.
Is it easily accessible?
No, no, no.
So for any large span headers beams, we just design it from scratch with
Yeah,
cast in place.
keep in mind what I told you. It's about 10%. For the design. Then they will come the engineers and work over that and see if that is a need. Probably. When you say that the pre-design is okay with 10%, it means that if there's nothing, strange on that, it will surely, works on that. Maybe we can stretch a little bit, depending on the number of rebars that we place or not. Okay, but I have to calculate it. It's impossible to say exactly if there's a way. I have my spreadsheet. Yes, I do have it. But it's not something that is available for the general public. That's also you wouldn't. Usually the people wouldn't understand properly.
Okay, okay. So you mentioned pre-design. Is it something that the designer engineer sends to you and you run the design? That's the pre-design.
The pre-design I'm saying, because imagine that you come over me and say, well, I have this design and I have to, and I would say, okay, well, do you allow me to do some changes here or there? Or you say, okay, no, it has to be exactly how it is. Okay? So I say, well, you do, here I have a span of, I don't know, 30 feet. Okay. So the panel, that can reach out that, it will be maybe a PSM, 240 with four choice. That's it on the table. Okay, there's a table for that. It depends on the manufacturers. Manufacturers has different tables for that, but it does exist.
So the pre-design is like a free resource from you
Yeah.
that you can provide. Yeah.
It's the first thing. You come over and say, "Hey, what do you think about this? Look at what probably I will require," and I will say, "Well, it will be much about this." Okay, then we have to get in. Because another time, maybe it doesn't make sense. I remember that also panels, has its cost. So maybe you say, okay, well, I mean, there's a lot of things on the way. Maybe I say, do you want to preserve every single wall as a sharing wall in the interior or not? Okay. So there's a lot of work to be done to make the most efficient way. Just make it, I mean, yes, about that, yeah, it can be. I mean, but it probably won't work for you.
Sure. One more question. So when back to the same 8 foot, 10 foot slider, if we have to put a cast in place header there,
Yeah.
do you expect a cast in place column on those stands, or the panel
Well,
can handle it?
usually when when there's some concentration load, I mean, it's probably that you have to add a little bit more room for concrete or mortar. Okay? So it does happen that there are places where I have to melt a little bit the wall, for instance, to make room for some internal column, let's say. Okay? So it is possible. Yeah, I mean, it has been done. Also has been done. For instance, back in Sarasota, there are houses that maybe has a wall that has like 30 feet, I would say, and they only have just one wall perpendicular. Okay, so the pressure of the wind is so much. Okay, so much. So probably not. I make some vertical choice. Okay, to take that pressure. So I melt a little bit those panels from the interior and create some kind of choice for providing that stiffness. If not, it won't happen that house will turn down. What it happens is that it will vibrate, more than I will like.
Okay. And all those you mentioned melting a little bit. That's like per designer, right? Per engineer. You don't provide any.
No, no, I mean, of course, I do have details for that, but I mean, we use it as, as for the different projects. I mean, depending on the condition. Yeah.
So back to the same slider. So if we melt, like you say, melt a little bit, it's you basically saying figure out how much we need to melt, how big the column needs to be.
Yeah, but keep in mind that when I'm saying that, I'm not saying that, well, that's a big deal. I mean, when I say melting, I'm saying, you know, rip out, let's say, or melting up 2 inches, behind the mesh, or maybe an inch and a half, no more than that. Usually placed, two rebars vertical, and something that works like this, guys. Okay, so basically that is what it happens. I mean, then the other thing is to see where they have to be placed, because the length is 30 feet. Okay, so I have to see how they come up, the numbers, and see where is the place where it's more efficiency to place it.
And is there a table of max point load on a panel?
Yeah,
Can you do me a favor and repeat the question?
which one?
We're having a problem with this mic, so when he asks you a question, if you could repeat it into
Oh.
your mic. Yeah.
There?
So this
So
is
that, yeah.
It's
No,
not.
I'm
It's
sorry, what
not
was
coming
one
over.
more time?
which mic?
Oh, he's. I'm sorry. Well, uh, okay. Now he is asking about the maximum loading capacity. You're speaking about for the floor panel. Yeah, yeah. There are tables. I told you that there are tables of the different manufacturers that tells you about the capacity for walls and for floors. Okay, and for floors, I mean, you have like three things. I mean, the shear capacity, you have the moment capacity, and the deflection. Okay, so according to that, you have a table, and you can use maybe, for instance, okay, let's say a panel of 240 millimeters, for instance, or you can have a panel with two choice, or you can use a panel of 200 millimeters with four choice. Okay, so you can do the combination that you please. That is also important, so you can see, I mean, what's the clearance that you want to expect to have on the ceilings or whatever. Okay? And if you want to have room, trace whatever facility you need to be traced, if you need to trace some facility inside the panels of the floor panel. The vertical concentration, also there's a table for walls, and those tables also, I mean, apply for the loading capacity, the backlink, and so they give you an idea of, of which panel, the height, the maximum height of the panel, taking care of the thickness.
You were estimating per linear foot.
Yeah, yeah, that's right. That's absolutely right. I mean, it can be increased if you increase the, I mean, instead of having 1.5 inch, you have 2 inches, for instance. And of course, it will increase if you use, instead of using the most used mortar of 4,000 psi, you use 6,000 psi. Is it? Scott? Yeah.
What I would say, the question is material science and trying to design by material science will never get you to the capacity of what these panels are capable of. By and far, the best way to do it is with physical testing and using and physical testing will get you to that and capacities of beams and stuff stabilized are available. And so with the physical testing, it gives you
Well, the physical test provides you the input to place the input on the software, okay, and and then come out with the result of each case. But yeah, there's no table precisely for every matter. I mean, besides, they're really good. I mean, it helps you out. It provides you some guidance. I mean, that's true. I mean, but then it has to be verified.
I just as a statement of
Exactly.
into it because it's a nice picture, um, really really good resilience like that.
I mean, the loading capacity of wall panel in my shots is super high. Okay, it's super high. I mean, but you have to keep in mind that is just for dead and live loads. But then you have uh, uh, wind loads and other loads that it can uh, tell right away. And also, of course, imagine that you have openings. So you have to see how they match with that. It's not that super simple.
And we had another question.
Okay.
Say it loud into your mic. What are for architects that are starting now, what do you see as the biggest challenge to understand to be able to design with this and use it in their projects? What do you think that the key points of understanding and concepts are for them to understand?
Well, perfect. Well, the first thing is that they had to be confident on the system. Okay, the first thing, uh, and having that in mind, I mean, if I would say, the most efficient way to work with the panels is having like a simple structure. Okay, simple structure. I mean, like I have a box. The box has openings. Um, Try not to have slope here, slope there. One side, one the other. I mean, regarding the possibilities of structural speaking, there's endless. I mean, there's no problem at all. I'm speaking about more than the efficiency on working on the field and having something, make it cheap enough on time, okay, and that doesn't require a very sophisticated labor. Because the system really is not sophisticated. It's not difficult to work with. So the only thing is that we have to try to make the project like a little bit more simple.
And then what are the concepts that they need to understand for like
And the other thing that I would say that you have to keep in mind that it's not necessary for the high capacity that the system has to have everything as bearing walls. So, so if you want to have a lot of wall for a closet, this coming in out and that, leave it for frame. It's no problem. I mean, it's not a need to make everything out of skip. I mean, what we have to keep in mind is what is strictly necessary, and then whatever you want to move to make more, we can. Okay, there are people that want 100% on skip. My only advice it would be keep the benefit, and the benefit from my perspective is that the capacity for the wind load, I mean the risk of hurricane, the fireproof, and the insulation. Okay, so so everything that doesn't affect that, it's okay.
Yeah, really loud. I was listening. I think get started with this kind of product in this area here. So there's a lot of new things. I think the thing to really push to sell with this is seems like most of it you can use this product for the entire shell.
Yeah.
But you do not have to have precast pieces or even form things. But like the gentleman's question in the back, it's the same question I have. Is if you're looking to do this for a standard house in the US, I'm just throwing out an example. You have a 16-foot garage door, got a 8-foot garage door, and then have a wall. Can you put a 2-foot piece of panel there to do that? Or that's why that's the table. Do I need to have 3 foot? Do I need to on that? So there should be some quick answers. Like we're going to start designing with these things. I'm an architect. We're going to start designing with these things. What are the limitations on span and things that we can do with pushing this panel right now? Dictate height for especially for
Well,
just throw that out.
well, Joshua, the first thing to mention is that regarding the capacity of the wall, I mean, they are extreme. So basically everything can be done. The only thing that there will be some limitations when when the length of that wall, and speaking about external walls, places where there's a high wind load. I mean, and then you don't have perpendicular walls. Okay, so you have to see if you have perpendicular walls or not, and if you have the floors. For floors, we get over that. We say that there are tables for that. Okay, and for simple panel, usually keep in mind that maybe 16 feet is it's the maximum that you can get on span, okay, a single panel. And when the panels have then you have the pockets, the choice, I mean, you can go up to 32. Okay, depending on the thickness of the panel and the number of pockets that you have. Okay, and there is a table for that. That tells you for the loads that you have, the share that you can take, tells you about the moment, the maximum moment that you have, and tells you about the deflection. Okay, so everything is contemplated there. Okay, so you can choose, and there are options, as I mentioned. I mean, it's not like there's just one panel for that. Okay, because you can use either a panel that is, more thicker but with less choice, or you can use some thinner with more choice. Okay, and it's up to you. And it's not up to you just because, well, I mean, there's a lot of things and they're involved. I mean, if you have more choice, you need more rivers, you need more syrup, you need more concrete. Okay, you probably ended up having more road. Okay, but you make the construction, more thin, more short. Okay, so there are things. I mean, you have to choose your path. Those tables provide you an idea to work on. Then it has to be some speak. I mean, we have to, to work together and see, okay, what you are looking for. I mean, your ceiling. What the height, the clearance that you need? What's the total? So out of that, I can tell you right away that because I wouldn't be working with. I mean, that's the idea. I should go with you, Tim. Wait a sec. And then and regarding the values for the beam, keep in mind that 10% basically is how it works. The 10%. But keep in mind this other thing that I haven't mentioned most at all. Although, since you're speaking of something that not only takes the compress pressure that you use also the traction. What you, I mean, you can work every wall out, upper wall can work as a inverted beam. Okay, so for instance, if I have here, for instance, this header, and the header wouldn't exist. Okay, so you go up to the top, and then the following, okay, we have there, a wall over. I mean, that's my header. I mean, so I don't have to, to think about that. It's about the concept. Tim, how are you?
So, it's great to see you.
Yeah,
So,
you too.
can't wait to catch up. But, the guys are asking questions. I mean, we were talking with the number 4 GFRP and the mortar at the spec we were talking about
Yeah.
today, which is a pretty standard shot, minimum 4.
Yeah.
But this is literally 10 times the strength of an LVL. So if you just want to, and I just want to make sure, because this is how I thought of it. If I just do the old numbers, like
Yeah.
as far as a thickness of a beam,
Yeah.
and I shoot that up in with type of mix we're coming up with and everything, it's always going to should always be good, right? I mean, it's like if an LPL would do it, an LPL would do it.
Yeah.
And then if we don't have time to run the numbers, we put a 60-minute skip in with number 4 GFRP bar, 4 rods, bottom.
Yeah.
We shoot that with our pick. You know, you've got at least 10 times the strength of an LPL.
Yeah, I remember that. I mean, mainly, I mean, the what it works better. I mean, for for the system is more. It's about the compression capacity and for the full or traction capacity. Okay, so meaning that means that uh, I mean, when you have a beam, for instance, of steel beam, usually you take, for pre-dimensioning, you take, let's say, a little bit more than 5% of the span, okay? 5% of the span when you have a steel, okay? When you make it out of concrete, it's about almost the same than what's the reason, the difference between them? Well, the skip will deflect a little bit more because the core is empty. The core is empty, so it's not as rigid as something that is 100% concrete. Okay, but the concrete has more weight. Okay, so it's nice balance both things. So basically, you keep in mind like a 10% that would be good enough, and the 10% I told you, I mean, you can make it either goes if you depress all the foam that is on the floor, okay, and incorporate that 10% considering the thickness of the floor panel, okay. You understand what I'm saying? So the header, here's the floor panel, and here is my beam, okay. So the place where you are in contact, I mean, I I take away I depress the foam, okay, and I incorporate the height of this floor to the header. Okay, so I take the 10% considering the top of the floor. Okay, so that if I don't do that, that 10% goes from the ceiling, to the bottom of the header or the beam. Okay, so that's basically how it is. But if you have, remember on your model, okay, remember that I offer you to make one wall working as an inverted beam. So in that case, you don't have anything. The thing of working as an inverted beam is that that change you the procedure of the building procedure. Remember that I told you that you can take away all the shoring until that wall that is on the upper level is already working. Okay? So that's the things that has to be contemplated. But I don't think there is much, you know, complex this. I mean, another time for walls, almost no restrictions. I mean, just if it's exterior and it's too much large, keep in mind that probably we need one or two choice vertical. If it's a floor, there are tables for that, or a roof, and it's being usually conceived like that 10%. Remember that maybe it's just a wall over. You can use also even part of the header and what you have over. I mean, can be incorporated, and of course we can mix it with other things. I mean, we want to make that um, beam instead of making out of skip, make it on concrete. We do it. We make it. We want it combined with. We can do it. I mean, it depends on what you are looking for. I mean, and when I'm saying looking for, I'm saying, I mean, what's the total height of the building? What's the clearance between floor to floor? So, I mean, we make it, and it's not really complex.
Lot of kind of clear, finite elements analysis. You
Yeah,
actually do that. You see, oh yeah, I have a wall above, yeah, it's actually an inverted beam or whatever the situation is. You can kind of
yeah,
see that better.
but beams. I mean, unlike the other, it's not that difficult to pre-design as an isolated element. Okay, much easier. I mean, what is impossible to design as isolated element is the wall. Because the wall, you don't know precisely what the loads are and what we are speaking about. Are we speaking about just, the dead and live loads, or we are speaking about the, obsessive load, or we are speaking about, so there are a number of things that only can be seen, when you modulate that and you see. The beams are not that complex, to be honest. Yeah, sure. Yeah.
So I'm going to ask two more questions from our virtual audience so that we can wrap up with them. I'm going to give a quick overview on the North American SCIP Association, and then you have lunch for all of our in-person attendees, and we can continue to discuss and ask more questions with Lucas while he's here with us. Sound good? So the two main common topics coming through the comments section, you have some fans, people who know who you are, and they're tell Lucas to talk about this, tell Lucas to talk about that. So they mentioned, can you touch on waterproofing the wall panels to the slab and touch on a couple of different other concrete applications like cast in place with the walls, or the poured concrete process, and anything important there for architects and engineers?
Well, the first thing about the waterproofing. Waterproofing, I mean, if you take the concrete as a whole and you make it good enough, the concrete is almost waterproofing. Besides, of course, I mean, there are additives that you can place to ensure that. Okay? Um, we use mostly a product called Penetron. I mean, for that can be, I mean, add on the mixture. I mean, but that since the mixture in this case usually is a premix and someone make it. I mean, when we do it on site, we might add that product. It's an Penetron add mix. If not, it's paintable. So when you ended up, I mean, spraying the mortar, you can, paint it. That it's super simple. The roll, you just place it, you place with a little bit of water, and it's not that much. And it's good because if you place it, the funny thing is that if there's some problem, it will, pump up, some cracks. I mean, it will show it as white, like, so that's something that works a lot. The thing that always, is important is not to have, for instance, the panels, at the same level from the exterior from the interior. Okay, so things like that are, something that you have to contemplate. The same thing happens to the foundations. I mean, if you wanna add penetrant, that is a good thing. I mean, to make it. So that those, I mean, those are, what is mandatory, okay? And work over as, for instance, you have a roof, and the wall gets over the roof. I mean, place some membrane. I mean, everything that you have a connector, connection exterior that is, a horizontal one, that is uh, that is exposed to the rain. We will have to place a membrane there, okay, on that joint, and a coping on top of that wall. Okay, that's that's mandatory. The other question was, sorry.
Um, quickly touch on poured
Okay.
concrete, precast,
Yeah.
cast in place.
Okay. Okay. Well, um, well, to place to use the panels on forms is something that it has been done. And I won't. I mean, I will say the same. I mean, I have a few clients, but they did a lot. I mean, why? Easy. The forms are not okay. So the people that works on forms, I mean, they have to use much the form to regain the investment. Okay. So so it's not for for a house. I mean, if you're thinking about the house, unless you're really a millionaire, keep that out of your mind. Okay. So so that is it won't work. Of course, there's a different. I mean, actually, in a couple of days, I will be performing a presentation about that, but in Spanish. Okay, so that will be in 2 weeks. So, um, so the other thing, of course, basically the people use aluminum or PVC, okay, forms. Okay? So the thing is that to return that investment, usually it takes. I mean, the manufacturer will say that you can use, I don't know, 200. Okay. The problem is, do you have work for 200 times? So usually my number is the other way around. I mean, do I have, let's say, 40 times to use it? I mean, to pay off that. So that's the equation that you have to do. I mean, and now speaking about benefit or not, well, of course, the main benefit is that you are faster. The finishing, if you like the smooth concrete, can be really nice. I mean, and always take no time then to finish. I mean, just some protection that you place over it, and that will be it. And so that works really well. The other thing is that usually, I mean, even when you can do it with panels, mostly of the cases, the floors are just concrete alone. Okay, there are cases that someone produced the panels without foam, so it's like you have the mesh, on top and bottom, and you have the connectors, and you fulfill with the concrete. Okay, so usually, well, I mean, when it comes to the roof, you have to add then insulation. Okay? But I do have some examples back in Argentina, really nice. I mean, for two things. I mean, the houses that are, really premium houses with a set of, everything, solar and this and that, and in the main of the forest, and they are really nice. And also we have some buildings with a time lapse that you can see, how far they make it, and they really have astonishing numbers for that. The problem with that is this. See, when you spray the mortar, see this horizontal wire. This horizontal wire is in contact with the foam. Okay, I did my my test alone, and when you spray the mortar, I mean, the mortar produces some heat. I mean, depending on the number of cement that you have, but it will heat. Okay, so that's the process of the curing. Okay, that's why you have to restore that with water. So that means that with the pressure and with that heat, I mean, it melts like 2 or 3 millimeters below that wire. Okay, but when you do it with by pouring, I mean, you eliminate part of that. You don't have pressure. Okay, so what it happens is that this horizontal wire is not really full covered from behind. So I do have people that use this panel, but I have to mention that and for pouring, okay? And of course, you need a spacer. I do have those spacers. I mean, that you click on. And unfortunately, I don't know why I didn't bring it. I have here right in the state, and it's you have for 3 centimeters or 4 centimeters. So you ensure that. that you can have, centered the panel inside the phones. Okay, so and you can also use it that for what? For placing, for pouring actually the ceiling. Okay, so you place here the spacer, you make a space here, and you make it happen. So that's something that, well, actually in Sarasota have used it on some. So that's it's a possibility. The thing is that if you wanted to ensure that the covering of the horizontal wire is good, there's a special design for that that has like strips instead of having these waves. You have strips. Okay, so you have one strip coming out and one strip coming in. Okay, so you just have along the panel of the width of the panel 6, and that's so that is makes that the contact with the wire is no more than 8% of the wire. So, and the other part is super fully covered. Okay, super fully covered because you have like almost an inch behind. The problem with that is that you end up having a thicker wall. Okay, you probably add 1 inch or more to the wall. So that's one of the issues. Then it's a little bit more difficult because another time you lose a little bit of the foam. So for tracing, you don't have so much room for that. So there are people that place it over. And if not, you use this one. The problem is with the horizontal wire. And and and, and finishing this up for precast. Well, precast is almost the same, but it has main benefit is that you don't have. I mean, to ensure that you can pour the concrete, you have to have concrete that is super fluid. Okay, usually it's a self-leveling. Okay, so it's almost like water. Okay, so the problem is it's a little bit more expensive. It works perfectly, and I have a lot of examples where it comes out the finishing perfect. The problem, the good thing another time is for the guys that already have the form, nice to try it on. I mean, because they had the expertise, so they don't have to know much more. I mean, so you don't have to learn anything regarding, spraying motor or whatever. I mean, it's super easy. But coming back to the precast, you don't have limitations because the other, I mean, you pour, I mean, let's say from 8 or 10 feet, and that means okay that you have to vibrate a little bit and have enough room for for cooling it properly. Okay, while if you are working with a table where for precast, that happens automatically, so you can reduce substantially the thickness of what it is involved. Of course, you need another engineering. I mean, precast it can be done for standardized panels, or you can do, for instance, this wall. We say, okay, well, this wall is this length, this high. Well, which crane you have? I mean, and you say, well, I have a crane of 30 tons. Okay, well, we have to divide in three. No, but also, I have a bridge, this and that, and the maximum that I can, have on the, on the track is this area. Okay, so after that, you make it. Okay, and but that's the limitation. And coming and so to end it up the conversation, so that's why another people say, how about if we make it at the shop site? So we don't have those limitations. Okay. And that's where it comes the tilt up. Okay. So basically that is how it happens.
Thank you.
Okay. Thank you everyone.
A huge thank you to Lucas and Casa Forma for making the trip from Argentina. I think it's clear that we've only scratched the surface of his knowledge from 20 years of experience, 17, so almost 20 years of experience with SCIP technology and a lot of the questions like you guys want to know next steps. Where can we get the engineering tools we need or the architectural tools we need? And I wanted to reiterate, you guys are part of the first educational event hosted by, or in partnership with the North America SCIP Association. So this association was just launched in September by Fortified Structural Solutions. We are just one of the multiple SCIP panel manufacturers here in the U.S. And we kind of touched on how this is so prevalent all over the world, but innovative building methods it's challenging for them to take off here in the U.S. and prevalent and widely adopted and scaled. So it falls the responsibility of manufacturers to develop the products and resources that you guys need to be able to design with the system, and we understand that. So part of what we're doing to face that head on is creating the North America SCIP Association. It's an online digital center where any professionals, you know, notice discrimination. All manufacturers, all vendors are invited to be a part of this. We even have one of our direct competitors, Scott Miller with DCT, sitting in the back of the room. We welcomed him here. So we understand that we have to work together as manufacturers to improve the reputation of the SCIP system and get it more prevalent and widely used. So we are accepting founding members through the end of the year. I know a lot of you in here are already members, but that's exactly what's coming for you is resources that you need. So whether it's CAD files or Revit packages or things like that, I recommend you go ahead and speak with your representatives at whichever manufacturer and talk to them about what they have and what they're working on and developing. Um, whether there's an engineering consultant that you can discuss with. Obviously, Lucas and Former are a huge resource right now where they can provide drafting services to you as an engineer of record if you'd want to start exploring how you can be involved in SCIP projects in your area. Another thing that we're going to be doing is in-depth case studies of all the projects that are in the works right now. There's one on 30A done by Atrium Construction, Kent Hendricks, a very reputable SCIP industry expert, is leading the charge on that project, and there will be a group going to visit that job site right after this if you're interested in attending. It's in Santa Rosa Beach, 30A, so the west side, so it's really not far from this facility. Um, and and um, and this will also be a place that we're going to be launching a membership portal, so you'll have access to a directory of manufacturers, architects, engineers, installers, developers, general contractors that you can connect with directly, and the manufacturers are no longer the middleman in making those introductions so that projects can happen. So there's a lot in the works to expedite the process of SCIP being accessible to everyone who wants to use it and build with it. And with that, I know that there's a lot of builders that have been joining virtually, so I'm just going to switch this slide here because everyone has been asking. A lot of what we've been also doing for builders and installers, we have lots of training events for them as well. We host demonstration day events, which is a basic overview of the system and how it comes together and how the concrete is applied pneumatically with pumps and tools. But then we have 2-day trainings for those subcontractors that are actually developing their business around getting ahead of the game and becoming a SCIP installer so they can work with other GCs that want to, be innovative in their field. And then we are also trying to make the panels more accessible because right now you're going to the manufacturer, you're submitting your plans. This is for permanent projects, of course, and you're getting a takeoff performed, and you're getting a quote, and you're taking that as part of your materials costs, and you're going back to your budget. And so there's a long process of going through the design phase, as you know. But there's also a lot of uses for these panels outside of large permitted projects like custom home builds or multifamily units and things like that. So we are launching the first online storefront with Fortified Structural Solutions where you can get quickly shipped SCIP pack, SCIP kits delivered to your location across the US. And this will allow people to build walls and structures that are pre-calculated for them. So they'll be able to calculate their structures and wall dimensions directly through the storefront and add it to their cart and ship it to their location, where they will, they'll get a downloadable manual on the basic installation processes and mixes, recommendations, tools, links to where you can buy the basic level tools to be able to do this. And we're going to let the DIY contractors of the US tell us what else these panels can be used for. It's great for teams that are just trying to get trained up, doing demo projects on their own land or at their own, plants and locations. So that's what's coming, and I wanted to get it out there to all of the builders that are tuned in virtually. And thank you guys for attending. And we'll get some lunch, and then everybody can continue discussion with Lucas. And you have both two manufacturers here. You got Fortified Structural Solutions and General Gulf Concrete Technology here as well. So let us know if you guys have any questions there. And yeah, we'll visit the job site later on as well. So thank you, everyone, and let's eat.